Hello boys and girls, welcome to week 13 of remote learning. That's right, 13. One more than 12, which was last week, but one less than 14, which will be next week, our last week of school. But we are in 13 right now. Before I explain the game that we are going to play today, I usually read you a book. I decided to do something different today. I am going to read you a poem about math, a poem specifically about multiplying in math, because you guys should know by now that I am a very, very strong believer that if you guys take the time and put in the effort of learning your multiplication tables from memory, that it is going to make all the other math that you do from the rest of your school career that much easier. I really, really, truly believe that. I wouldn't keep telling you this if I didn't believe it with all my heart and soul. So this poem is called The Commutative Property. I have a number sentence. I write two factors down. When they're multiplied together, a product can be found. Now flip-flop these two factors, and what do you see? The answer is still the same because I just did the commutative property. So 2 times 3 is the same as 3 times 2. 9 times 3 is equal to 3 times 9. And 7 times 4 is equal to 4 times 7. It's the same for any multiplication problem. If you flip-flop the numbers or turn them around, we used to call it the turnaround rule. Now they're flip-flop. The real name is the commutative property of multiplication. The answer is the same. It doesn't matter what you call it. Okay? So if you know 2 times 9, you are going to know 9 times 2 because the product or the answer is exactly the same. Okay, so you also might be asking the question, Mrs. Tibbetts, you've been having us play games. How is that going to help me remember? It should help you remember. And it's important because it's also a standard. I've been telling you it's a standard in 3rd grade. And if we were in school, it would be posted somewhere. But here it is. Know from memory all products of two one-digit numbers. So that's from 0 times 0 all the way up to 9 times 9. You should know it from memory. 8 times 7 is 56. 6 times 6 is 36. 5 times 4 is 20. 3 times 9 is 27. You should know it from memory. I promise you, you're going to thank me if you do this. So anyhow, multiplication tic-tac-toe, that's what we're playing this week. All of you have played tic-tac-toe before. You get 3 X's, 3 O's in a row, across, down, or diagonally, you win the game. So now we're going to throw some multiplication in it. Game is for 2 players. One player is X, one player is O. I would recommend having 2 different colors. You're going to take turns, just like you do with the plain old X's and O's. But this time you're going to solve a multiplication problem from the board. You place an X or O, whichever one you are, over the problem if you solve it correctly. If you don't, it's still a free square. The first person to create a line of 3 is the winner. The line can go across, down, or diagonally. Okay? So here are 6 boards. You are going to copy them on paper. Okay? But I'm going to demonstrate how you would do it. So the first player goes, X's always go first. Okay? I'm going to choose this one. 7 times 9. 7 times 9 is 63. Make an X there. The next person goes, they're going to go here. 2 times 6. 2 times 6 is 12. They're going to put an O there. Back to the X's. 7 times 7. 7 times 7 is 49. We're going to put an X there. Now it's the O's turn. 9 times 9. 9 times 9 is 81. You're going to put an O there. Look at this. The X's can win. 5 times 3. 5 times 3 is 15. X's win. Boys and girls, I know that you guys are going to have fun, tons of fun playing this game. You're going to send me a picture of your completed tic-tac-toe boards. You're going to attach it to this assignment, send me a chat, or email me at btibbets@schools.nyc.gov. Have fun. See you next week. Bye.